Okay, there on the back, there are some instructions for, excuse me, working this out. I'm going to show it to you, and then we're going to draw the conclusion together. It says, find and mark the midpoint M of chord A, B. All right, so the midpoint is the point right in the middle, thus midpoint, right? So the point right here in the middle. Now, if you were doing this on your own, excuse me, then you would need to measure, and that's not exactly in the middle, is it? You would need to measure the length of AB and then find out what distance would be halfway in between it. So this is our midpoint M, that purple point, that's supposed to be an M there. And then it says draw a line OM. So a line that goes through the center O and through the midpoint M. So there's that line. And it asks for the measure of the angle created at point M. So I'm going to take my protractor here and I'm going to center it right there at M and line it up along AB. It's a 90-degree angle. So on your, whoops, moved the wrong thing there. On your picture right there, I need you to mark a 90-degree angle. Okay, that's a 90-degree angle. It's a right angle. All right, so let's fill in the blanks in this statement here. It says a line through the center of a circle bisects. What does bisect mean? Cuts in half. It cuts a chord in half if and only if the line is perpendicular to the chord. What does perpendicular mean? Forms a right angle or a 90-degree angle. Okay, so that's what's happened right here. We have a chord, AB. We have a line that goes through the center of our circle, and this chord has been cut in half, and where it's been cut in half, it's created a right angle. Okay, so we're going to use this because anytime a right angle is involved, typically what do we deal with? Right triangles, right? So let's use that. Number 4 there on your paper says, suppose that a given circle has a radius of 6 inches. What is the length of a chord that has a central angle of 115 degrees? So on your paper there, I have a circle with the center marked. And up here, I already have about 115-degree angle. So if you can kind of sketch that in your circle there, make it look about the width of what I've got up here. So let's label what we know. The radius of this circle is 6 inches. So I can mark 6 inches here. I can mark 6 inches here, because those are both radii, correct? It wants the length of a chord. So what this is talking about is if this is 115 degrees right here, it's talking about this chord right here. It's wanting to know the length of that chord. So we're going to have to use some trig again. And if we use what we just learned, if we draw a line that goes through the center and that cuts that chord in half, we create a right angle, okay? We need right angles here. We need a right triangle. All right, so I'm looking for the length of that blue segment. I'm looking for the length of that chord. But what I can find right now is I can find half of it. Okay, I can find half of it. I can find this length of it right over here from the edge of the circle to the middle of my chord. Now, if it cuts that chord in half, it also cuts that angle in half right here. So if the whole angle was 115, then the angle that's in our circle is half of 115. So it's 57.5 right here. Okay, so that angle within the triangle is 57.5. So let's label the sides of our triangle. Let's label the sides of our triangle. 6 is what part of the triangle? What part of the hypotenuse? Okay, 6 is the hypotenuse. Okay, we've got an X over there. Is that the opposite or the adjacent to the 57.5? Is it touching the 57.5 or is it across from the 57.5? It's across from it, so across is opposite. Which trig function is opposite over hypotenuse? Which one's opposite over hypotenuse? Sine. Okay, so let's set up the sine ratio here. We've got the sine of the angle, 57.5 degrees, is equal to the opposite is x, the hypotenuse is 6. How do we solve for x? What's happening right now? What's happening to x right now? It's being divided by 6, so what's the opposite? Multiplying. We're going to multiply both sides by 6. So 6 sine of 57.5. What do I have to make sure before I press enter? It's got to be in degree mode. My angle's in degrees, so my calculator's got to be in degree mode. Mine was not. I would not have gotten the correct answer right there. Bless you. So 5.06 is x. Now that's not the whole answer. Remember, that's just half. That's my opposite side right here. That's just half of that whole chord. So I have to turn around and I have to multiply that by 2 to get the actual answer. 10.12 inches is the answer they're actually looking for. Okay, so multi-step problem, but we've just got to break it down piece by piece. We got to write down what we know. We got to see how we can use what other knowledge we have to get there. Okay, let's look at B. What is the measure of the arc of a chord that is 8 inches long? Okay, what is the measure of the arc of a chord that is 8 inches long? So let's write down what we know. We still know that the radius is 6. So I'm going to put that on my picture. It says the chord is 8 inches long. So the chord goes from here to here. That whole thing is 8. Now, this all comes down to we got to use that whole cut the chord in half right angle thing. So let's go ahead and do that. Draw your right angle in here, cut it in half. I'm going to go on the right side this time just to show you it doesn't matter which side. So that piece right there is 4. So the question is, what's the measure of the arc? Well, to find the measure of the arc, we got to know the measure of this central angle. So we've got to start with this part of the angle right down here. This is what we're looking for. Let's label that with the theta. Okay, angles are labeled with thetas. So let's see here. What do we have this time? 6 is still the hypotenuse. How about 4? Is that beside the angle or is that across from the angle? Across, so it is opposite. So we've got opposite and hypotenuse again. This is sine again. Okay, but this time we don't know the angle. We don't know the angle this time, so we put a variable there. That's equal to the opposite 4 over the hypotenuse 6. Anybody know what we do there? If we're solving for the angle. The opposite, the inverse sine function, it's on your calculator. You press second sine. second sine of 4 over 6, so 41.81 degrees. Okay, but it wants the measure of the whole arc. That's only part of it. That's only half of it. So we got to multiply it by 2. 83.62. Is the measure of the arc. Okay, now this is using the same picture. What is the perpendicular distance from the center of the circle to the chord? So that sounds really fancy, but it's just asking for this distance right here from the center of the circle to the chord, and it's perpendicular because we got a right angle right there. How would we find that length? How would we find Pythagorean theorem? We got a right triangle, right? We got 2 of the legs, so we set up our Pythagorean theorem. So, a squared plus, what's b? Is it 4 or is it 6? 4. 4 is the legs. 6 is the hypotenuse. Okay, so we've got a squared plus 16 is equal to 36. So subtract 16. A squared is equal to 20. Take the square root. Here's a good chance to, I know we can type it into our calculator and get a decimal value for it, but here's a good chance to review simplifying radicals. 20 is 4 times 5. The square root of 4 is 2. So 2 square roots of 5, if they want it in square root form. But if they want it in decimal form, then of course, yes, you just type it into your calculator, and we get approximately 4.47 inches. Okay, so right triangles. Right triangles either require the Pythagorean theorem or they require using trig. Okay, we've done both with these. Let's look at one more scenario here. This time they give us another piece of information. So we've been given the angle, we've been given the length of the chord. This time we're told the perpendicular distance from the center of the circle to a chord. So I know all of my circles have looked exactly the same, but it's all good. So the perpendicular distance from the center of a circle to a chord. Let's draw the chord in there. There's the chord. From the center to the chord, perpendicular distance, that is 4. What is the length of the chord? Well, our radius is still 6. That hasn't changed. The radius is still 6. So we got 6 and we got 4. What is the length of the chord? So can we find half the chord? Can we find that other leg of the triangle? Yes, we can. And really, well, let's set it up. Okay, we got 4 squared plus b squared equals 6 squared. It's the same thing, it's just in a different spot, right? And my 6's and b's always look too much alike. So b is approximately 4.47, okay? But that's only this half of it, 4.47. That's only that side of the triangle. They want to know the length of the chord. So we multiply it by 2 because it's been bisected. 8.94. Okay. Well, let's answer one more question with this same diagram. What's the measure of its central angle? Okay, what's the measure of its central angle? So we're looking for the angle. Now, just in case we messed up on calculating the 4.47, let's just use the 4 and the 6. So 6 is still the hypotenuse. What is 4 in this case? Is it the opposite or the adjacent? The adjacent, because it's right beside the angle. Remember, if we make this angle symbol bigger, the other side that it touches besides the hypotenuse is the adjacent. So which trig function's adjacent and hypotenuse? Let me scroll up to where I had it written down. Which one's adjacent and hypotenuse? Cosine. Cosine is A and H. So set up cosine of the angle is the adjacent 4 over the hypotenuse 6. And we use the inverse when we're trying to solve for the angle, because we can't just divide by cosine. It doesn't mean anything. So the inverse cosine of 4 over 6, Jason is saying 48.19. But remember, that's just that one part of the angle. It wants the whole central angle there. So we got to multiply by 2 and get what? Thank you, 96.38 degrees. Okay, so in almost every step here, we've either had to cut something in half, or in the end, we've had to multiply it by 2 because it was only half of what they were really asking us for. All right, so when they draw that line from the center through a chord and it forms a right angle, then that chord is cut in half, that angle is cut in half, and you've created 2 right triangles that are the same. The left side and the right side are the same. They're both the same right triangle. Okay, so